My name is Marcin Prusiński. I work at the Seven Balls at the moment. I think it's okay if I go with this presentation because it's related to the clouds, actually. Yeah. So the project we are participating in, it's called Melodic, and what does this actually mean? I don't know the acronym. It's multi-something for cloud deployment, data awareness stuff. Yeah, it's really long, but let me just say that Melodic is for multi-cloud. So it's a platform developed to help you to do the automatic deployments to multiple clouds, not the single one. So it's like it's acting like a DevOps for your company, actually. And we are talking about a big cloud installations here, because for just some few components you don't need it. So yeah. And this thing will have the ability to migrate you from one cloud provider to another without actually the need for you to do anything. It will do it by itself. Yeah, and the most important thing here is that the calculation, the calculation of the selection is done with the use of, I like to call it the math with capital M, because we have this. I will show you later the set of solvers they are called, and the solvers just pick the right setup according to your requirements. So yeah, the reason behind this is you will receive no vendor lock. So you are not strictly assigned to a single cloud provider. Yeah, this is just a marketing slide, but yeah. The point is that the Melodic calculates the best deployment and deploys it for you. How it's actually done? Because for a multi-cloud, you have to provide some kind of abstraction layer between your application and the cloud providers or the cloud providers' APIs, right? To do so, there is this language called CAMEL. Don't confuse with Apache CAMEL. That's totally different. This CAMEL is it's actually becoming a standard for describing the cloud applications. It's based on Tosca. Maybe you guys heard of Tosca. It's a way to describe the applications in some declarative manner, and this gives you possibility to be cloud agnostic. So you describe the application in separation of the cloud providers. So you defined your application as a set of components, and you provide some requirements for the components. You can. This language is kind of complex because it wants to deal with this describing in like a really generic way. So from one side, you need to describe your application there in CAMEL, and cloud providers need to be described in this language as well. And this is, for now, this is the cloud providers are described pretty much by us in the project, but I think for the second release we have this thing on our roadmap that the cloud provider offers are automatically collected and just transferred back to the CAMEL. So, as I said, we described the providers. It's to group the applications in your organization. The deployment requirements for your components, like you want to deploy this. For instance, you have like application consisting of application server and a database, right? And you have some kind of requirements for the application server, like this must be run on a machine with a minimum of 4 cores and I don't know 8 gigabytes of RAM, etc. And for the database, you state that, for instance, you are obliged to have the data in Europe, right? So you put all of these requirements, so location requirements, hardware requirements, in the CAMEL, yeah, and then the magic begins to be happening. I will tell you about this flow later, but I will just briefly introduce the parts. So there is this profiler, which pretty much converts this CAMEL model to a constraint problem. So to something that can be solved as a mathematical problem. The problem is solved, and then by the adapter, the best solution that the solvers came with is applied to the cloud via the executionware part. But I will just.
How is it different from Terraform?
Yeah, it's because for Terraform, with Terraform the similar thing is that you describe the application and you have this abstraction layer from the clouds, but the Terraform lacks this actually this part, so the smart part. So for Terraform won't pick the best solution for you, right? So that's the difference, the main difference. Yeah, and in Terraform you pretty much describe this on infrastructure level, and here you describe on application layer. So the Melodic is like application aware. Okay.
And how does it compare to the combination of Terraform and Nomad?
No.
Because Nomad actually allows to describe the application part, whereas Terraform allows to describe the infrastructure.
Yeah, but does it chooses the right deployment plan for you?
It chooses the plan for the constraints you provide.
Okay.
Like you tell it in the configuration what you need. For example, I need a machine with so many RAM and the JVM.
Okay. Okay, but can you like because what you state here that you provide the requirements for a single component, right? Can you provide such a constraint that may, for instance, you have this application and database server and you need to put those in the same location?
I'm not sure.
Yeah? So yeah, I wasn't aware how it's called?
Nomad.
Nomad. Yeah, I will check it. Yeah, and if you can just leave me your data, we can take this offline and maybe compare. Okay.
So can I ask you a question?
Yeah.
Like you said that it will give you like a smart answer to your problem. What this smart means, is it a coast-wise optimization, or
Yeah, it depends what you exactly put in this requirements in this. It's called the goal function. So it depends how you define your goal function. So it can be cost, actually. Yeah, it can be. You can say that you want to maximize the performance of your application, right? So and somehow measured, because I will tell you later that there is this mechanism of sensors and combination of making some composite metrics and etc. So if you can measure something, you can maximize it actually. So yeah. So how does the deployment process look like? So yeah, this is pretty much what I briefly told before. You need to describe the application and the providers in the CAMEL. That's the first thing. Then you press a button and this CAMEL model is then transferred by the model called CP. It's constraint problem generator. So it generates this set of equations, variables, constraints, etc., and give this mathematical model for the solvers. There are 3 of them for now, and when the solution is calculated, then then the adapter is a part that makes that generates tasks then executed to the cloud in a proper sequence, right? So there is this graph generated inside to assure that, for instance, you need to I don't know, start the virtual machine before you install the application, etc. So yeah, then there is this Cloudiator, which is the execution layer. So via this Cloudiator, it's cloudiator.org, it's open source project actually. You can install this on like various cloud providers, and then you have this loop back from the running application. So the metrics are being collected and provided back, and there are actually 2 loops. One small loop is just through the adapter, because in this CAMEL you can, for instance, you can put some scalability rules. So you state that this application server can have like from 1 to 100 instances of virtual machine instances. And then this small loop checks, for instance, if some scalability rule is reached. So maybe you put a rule that if the average CPU usage for like last 5 minutes is over 80%, scale up. And it scales up. So that's the small loop. And then we have the other feedback loop, the big one. And the big one involves recalculating the solution from the beginning. So it starts the solvers again. So if you have like a big change, something you maybe you monitor the length of the queue and its ground, and then maybe that's a reason you should recalculate the better solution now. Or for instance, maybe your cost is too big for now. So you maybe need to switch for a bigger machine or to different provider, and then the constraint problem is generated again, and with this new set of variables equations, there is this new solution calculated. This is the Cloudiator architecture. So what I just want to state that there are these two domains. One is the local domain, so that's the Cloudiator instance, and then there is this remote domain. These are these small lightweight agents installed on the virtual machine to collect the data. We've built this melodic app with the main process. That's this deployment and redeployment process is made with the use of BPM process, and then all of the components are integrated with the use of ESB. We've used the Mule ESB here. Okay, so we got this meta solver. It's a gate to the solvers. So the meta solver has the ability to choose the right solver for a particular type of problem, because this can be really tricky, from a simple ones to the really complex because it grows exponentially, right? So if you have only two machines, you need to just two components describe, you need to do a little work, and then if you just add and add and add, it just makes the things really hard. So yeah, we have this. So the meta solver chooses which solver to use. So we have 3 of those. I will tell about them later. We have this solver to deployment, which is a model that converts the solution back from this constraint model to the execution model. So it's like adapter. And the adapter, which is preparing this execution graph and deploys. And adapter has this this feature to, if you have this redeployment loop, the adapter actually after preparing this new deployment graph, it just makes the diff with the previous deployment and just applies the diff. So yeah, if you have like 3 components and the solvers tell you that just one need to be moved from a provider to provider, then the diff says, okay, these other 2 components just stay the same and just move the third one. Okay. We have some database. We store the models in, and the SLR adapter is this small loop to scale up or scale out. Yeah, these models are not hit ready, so they are in this different color. The UI is partially done. In the second release we will have this security model, so all the communication between your application components can go through this security module for authorization. And the event service is going to be rebuilt. Yeah, and the 3 solvers I mentioned. We have this CP solver, which is for constraint programming solver. It uses the gradient method to find the optimal solution. So, the MILP solver. So it's multi-linear programming. So it's a set of, it's just a set of equations that are being resolved. And the third, this one is actually the most advanced. It's learning automata solver. It's based on reinforcement learning technique. The algorithm is like from 50s or 60s, but it was this is the learning solver. So it constantly receives the monitoring data and learns. So it's not. So yeah, the solution should be just improved constantly over time. Yeah. Okay, and as I didn't say, but the first release is this November. The first release of Melodic, and there are going to be the second, the year after, and the third 1 year after that. And we have plans to introduce the big data support via the Melodic. So we are going to use some big data frameworks. I'm thinking what's the plan for the nearest future, but just.
Is it open source?
The Melodic?
Yeah.
Yes, it is open source. Yeah.
Okay, and what's the business model
The business module.
of the company?
Yeah, you need to ask my boss. I just have, fun making it. So.
You are paid, right?
Yes, I am paid. Actually, it's a European Commission grant, so yeah, we are paid. Okay. Yeah, this is pretty much it. So if you have time, we are pretty much active on these channels, and yes, I will be happy if you are interested, just write me. We can discuss offline.
Do I understand correctly that it changes your infrastructure dynamically when your application is up and running in the cloud?
Again, please.
Does it change your infrastructure, your deployment, when your app is up and running on the cloud?
Yeah.
Okay. And second question, so how, I understand that there's some model that is optimizing some code functions that you find using this CAMEL language. So how do you decide on the first deployment?
First deployment.
First one, yeah, before you actually get some actual traffic and you can start optimizing those functions.
It's the same actually. You just don't have the measurements, right? But you have the requirements, initial ones. So if your requirement is to minimize the cost of machines, it just scans the available offers of the providers, and
but then if I need to optimize the cost only, I would say that I'm not gonna run anything in the cloud and it's gonna cost zero. I'm saying
but you provide the constraints there. So one of the constraints is that if you define a component in CAMEL, it means you want to actually install it in the cloud, right? So yeah, it will result in actually in creating this constraint that you should have at least one of those, and it probably will start with one.